Hey, Curious Decoders, welcome back to the Deep Dive. This is Season 1, Episode 2, and we're tackling a topic that's both mind-boggling and increasingly relevant: quantum computing.
It's certainly captured the imagination of many.
It has. But let's be honest, it can seem pretty intimidating, right? All that talk of qubits and entanglement, sometimes it feels like you need a physics degree just to scratch the surface.
I can understand that sentiment.
But don't worry, in this deep dive, we're going to break it down, make it easy to understand and explore why it matters to you.
The goal is to demystify this revolutionary technology and showcase its potential impact on various aspects of our lives, from healthcare to climate change and beyond.
Exactly. Quantum computing harnesses the strangeness of quantum mechanics, the rules that govern the very tiny parts of our universe, to do things that classical computers simply can't imagine, simulating complex molecules to design life-saving drugs or revolutionizing how we tackle climate change. That's the kind of power we're talking about.
Indeed, it has the potential to solve problems that are currently intractable for even the most powerful supercomputers.
Okay, let's unpack this. I often hear about quantum computers being exponentially more powerful, but what does that actually mean? What's the fundamental difference between classical computing, the kind we use every day, and this new quantum world?
At the heart of this difference lies the fundamental building block of information: the bit versus the qubit. Classical computers use bits, which can be either a 0 or a 1, like a light switch that's either on or off. A qubit, on the other hand, can be 0, 1, or both simultaneously. It's like a dimmer switch that can exist in multiple states at once.
Okay, I'm picturing that dimmer switch. It's not just on or off, but somewhere in between. That's the whole superposition thing, right?
Precisely. Superposition is a mind-bending concept from quantum mechanics that quantum computing exploits. It allows qubits to explore many possibilities at the same time, vastly increasing computational power.
So how does a qubit, being in multiple states at once, translate to actual computing power? It still sounds a bit like magic to me.
Think of it this way: with classical computers, you double the power by doubling the number of transistors, but with quantum computers, power increases exponentially with each added qubit. A quantum computer with just a few hundred qubits could theoretically outperform all the classical computers on Earth combined.
Wow, that's hard to even fathom. So what for us, what kind of real-world problems can quantum computers solve that are currently impossible?
One area that holds immense promise is climate change mitigation. Quantum computing could accelerate the development of crucial climate technologies, from renewable energy to carbon capture and beyond.
That's what I find really exciting. We often hear doom and gloom about climate change, but this feels like a potential game changer. So how does this actually work? How can quantum computing help us combat climate change?
For starters, quantum computing can revolutionize battery design. Imagine electric vehicles powered by batteries with 50% higher energy density, making them more practical and affordable, and driving the shift away from fossil fuels.
That would be huge. Better batteries are a key bottleneck right now for electric vehicles and renewable energy storage. But what about other areas like the massive amounts of carbon dioxide already in the atmosphere?
That's where carbon capture comes in. Quantum computing can help design new materials like specialized sponges called metal organic frameworks, or MOFs, that can efficiently capture CO2 directly from the air.
I've heard about these MOFs. They have a mind-bogglingly large surface area, right?
Precisely. Just 1 gram of a certain MOF has a surface area roughly equal to a football field. Imagine how much CO2 they could soak up.
That's incredible. If we could capture CO2 that efficiently, it would really change the game.
And that's just the tip of the iceberg. Quantum simulations could also help us create entirely new zero-emission processes for making things like cement and ammonia, both of which currently have massive carbon footprints.
Hold on, did I read that quantum computing could also help reduce methane emissions from cows? Tell me more.
You did indeed. Methane from livestock is a significant greenhouse gas. But quantum computing could be instrumental in developing an anti-methane vaccine for livestock, potentially slashing methane emissions by a staggering 90%.
A vaccine for cows to reduce methane. Now that's thinking outside the box. It really shows how this technology could touch so many aspects of our lives.
It highlights how quantum computing goes beyond simply faster computers. It's a fundamentally different way of processing information, enabling solutions we might not even be able to imagine right now. It's remarkable how quantum computing can impact such diverse fields, from the vast challenge of climate change to the intricate world of molecules.
It really is. And speaking of molecules, I'm eager to explore another area where quantum computing could be revolutionary healthcare. We touched upon drug discovery earlier, but the possibilities seem endless.
Indeed, the ability to simulate complex molecules and their interactions at an atomic level is a game changer. It could dramatically reduce the time and cost of developing new drugs and therapies, leading to a paradigm shift in how we treat diseases.
It's almost like having a superpowered microscope that allows us to see and manipulate the building blocks of life itself. But what are some specific ways quantum computing could change healthcare in the near future?
Imagine a world where we can design drugs tailored to an individual's genetic makeup. That's the promise of personalized medicine, and quantum computing can help make it a reality.
Personalized medicine? That sounds like something straight out of science fiction.
It may seem futuristic, but it's closer than you might think. By analyzing vast amounts of genetic data, quantum algorithms can pinpoint specific genetic markers that contribute to diseases. This information can then be used to develop highly targeted treatments, minimizing side effects and maximizing effectiveness.
That's incredible. It would completely change the way we approach healthcare, shifting from a one-size-fits-all approach to truly personalized treatments. It makes you wonder what other areas of healthcare could be transformed.
Quantum computing could also revolutionize medical imaging. Imagine MRI scans with significantly higher resolution, enabling earlier and more accurate diagnosis of diseases.
Wow, that would be a game changer for so many people. Early detection is crucial for so many conditions.
Exactly. And this could be achieved by using quantum sensors, which are far more sensitive than conventional sensors. They could detect subtle changes in the body that current imaging techniques miss, allowing us to diagnose diseases at earlier stages when treatment is often more successful.
It seems like quantum computing could revolutionize healthcare from diagnosis to treatment, leading to a future with more effective personalized and preventative care. But let's not forget about another crucial industry that underpins our modern world: finance.
Indeed, finance is another industry ripe for disruption by quantum computing. One area where it could have a massive impact is risk management, which is the cornerstone of the financial system.
I can see how that would be important. Financial institutions need to be able to assess and manage risk effectively, but the world is so complex and interconnected.
Precisely. Financial institutions rely heavily on complex models to assess and manage risk, but these models often have limitations. Quantum computing can enhance these models, making them more accurate and sophisticated, leading to better risk assessments and more informed investment decisions.
So it's about making the financial system more resilient and less prone to crises.
Exactly. By using quantum computers to better model and predict market behavior, we can create a more stable and secure financial system for everyone.
That's a huge potential benefit.
Yeah.
Are there other ways quantum computing could shake things up in finance?
Quantum computing could also revolutionize algorithmic trading. Imagine trading algorithms that can analyze market data in real time, identify patterns that are invisible to traditional algorithms, and execute trades at lightning speed.
So it's like giving traders a superpower. They'd be able to make decisions much faster and more effectively than humans ever could.
In a sense, yes, quantum computers can process vast amounts of data and make complex calculations much faster than traditional computers. This speed advantage could give financial institutions a significant edge in the fast-paced world of trading.
It sounds like quantum computing could reshape the landscape of finance, making it more efficient, secure, and data-driven. But with all this talk about revolutionizing industries, it's important to consider the potential downsides as well. We've talked about the incredible potential of quantum computing, but it's clear that this technology is still in its early stages. Where do we actually stand today? Are we on the verge of a quantum revolution, or is it still a distant dream?
It's a question many are pondering, and the answer is nuanced. We're not quite at the stage of having large-scale, fault-tolerant quantum computers readily available, but the progress in recent years has been truly remarkable.
So it's not all hype. There's real substance behind the excitement.
Absolutely. We're currently in what's often called the noisy intermediate-scale quantum era, or NISQ for short.
NISQ. That sounds a bit technical. What does it actually mean for the practical applications we've been discussing?
Essentially, NISQ refers to the current generation of quantum computers, which have 50 to a few hundred qubits. They're called noisy because these qubits are still quite sensitive to their environment and prone to errors.
So they're like the first generation of smartphones, powerful, but with limitations.
That's a good analogy. And they're intermediate scale because they're not yet large enough to tackle the really complex problems that we envision quantum computers solving in the future.
But even with these limitations, are there things these NISQ computers can do today that classical computers can't?
Yes, indeed. Even at this stage, NISQ devices are capable of performing certain tasks that are beyond the reach of classical computers. They're being used for research in areas like materials, science optimization problems, and even for simulating small molecules.
So we're starting to see real-world applications, which is incredibly exciting. But if we're still in the early stages, what are some of the hurdles that researchers need to overcome to unleash the full potential of quantum computing?
Scalability is a major challenge. We need to figure out how to build quantum computers with thousands or even millions of stable qubits. This will require significant advancements in both hardware and error correction techniques.
It sounds like building these quantum computers is a bit like trying to build a house of cards on a windy day.
That's a vivid image.
Hmm.
And then there's the challenge of algorithm development. We need more efficient and effective algorithms that can take advantage of the unique capabilities of quantum computers.
It's like having a powerful new instrument, but not yet knowing how to play it to its full potential.
Exactly. And of course, there's the ever-present need for skilled talent. We need more scientists, engineers, and developers who understand quantum computing and can contribute to its advancement.
So it's a complex and multifaceted challenge, but also an incredible opportunity for those who are eager to dive into a cutting-edge field.
Indeed, the potential rewards are enormous. Imagine a world where we can develop new materials with incredible properties, design life-saving drugs with unprecedented speed and precision, and unlock new sources of clean energy. Those are just a few examples of what quantum computing could enable.
It's a future worth striving for. But what can our listeners do to prepare for this quantum future? It all seems so specialized and complex.
You don't need to be a quantum physicist to engage with this field. First and foremost, stay curious. Learn as much as you can about quantum computing. There are so many resources available online, including articles, videos, and even online courses.
So it's about embracing lifelong learning and keeping an eye on this rapidly evolving field.
Precisely. Also think about how quantum computing could impact your own industry or field of work. Start exploring the potential applications and consider how you can leverage this technology to solve problems and create new opportunities.
So even if we don't fully understand the technical details, we can still start thinking about the potential impact on our lives and careers.
Absolutely. And finally, don't be afraid to get involved. There are numerous initiatives and organizations dedicated to advancing quantum computing. Attend conferences, join online forums, and connect with other people who are passionate about this technology.
It's about being part of the conversation and helping to shape this exciting future.
Well said. The quantum revolution is not just about technology. It's about a shift in our thinking, a willingness to challenge our assumptions, and a belief in the powers of human ingenuity to overcome even the most daunting challenges.
Well, curious decoders, we've reached the end of our deep dive into the fascinating world of quantum computing. We've explored the science, the potential, and the challenges of this revolutionary technology. It's a field brimming with possibilities, and it's one that we'll certainly be revisiting as it continues to evolve.
It's been an absolute pleasure sharing these insights with you.
Until next time, stay curious and keep those quantum minds buzzing.